So let's move on to the next question. The equation of a curve is y, given to you right here. Now we have to obtain an expression for dy by dx, so pretty easy. First thing first, we can rewrite this as this, x squared plus 3 power minus 1. So dy by dx is pretty easy now. 12 is 12, we don't care about 12. Here we have to first multiply by the power, minus 1. Then we have to minus 1 to the power, it should be minus 2. Multiply by d by dx of the value inside, that will be 2x. Now from here we can simplify, that will be what? Minus 24x over the value of x squared plus 3 squared. Okay, so here you will have this as dy by dx. Now for part 2, find the equation of the normal to the curve at the point P. So how can you find the equation of the normal at the point P? So pretty easy. We know the normal is a straight line. We have to first find the gradient of normal. Again, same concept. To find the gradient of normal, we must first find the gradient of tangent, because we know that the normal and tangent, they are at 90 degrees to each other. But also, this is simply what? This is simply the gradient of tangent is simply dy by dx. So we know this already. So let's find that. Dy by dx is equal to minus 24x over the value of x squared plus 3 squared at the point P where x is equal to 1. This is your x value and your y value. Replace, you will have minus 24 times 1 over the value of 1 plus 3 is 4. 4 squared is 16. Right? So minus 24 divided by 16, that should be minus 1.5. Okay, so that will be my gradient of tangent. Now because they are perpendicular to each other, as we have seen before, we understand that the gradient of normal multiplied by gradient of tangent should be minus 1. Replace this back, you will have this multiplied by minus 1.5 should be minus 1. So this is pretty easy. Minus 1 divided by minus 1.5. That should be the value of 2 over 3. So this is the gradient of the normal. Now you have the gradient, you have a passing point, you can find the equation pretty easily. So y minus this corresponding value, 3, x minus this corresponding value is equal to the gradient. Now again, this is just the method that I use to find the equation of a straight line. If you have your own method, you can use your own method as well. Cross multiply, you will have 3y minus 9 is equal to 2x minus 2. 3y is equal to 2x minus 2 plus 9. So 3y will be 2x plus 7. That is my equation of the normal. Again, you can always make y become subject. It is up to you. You don't need to do that. Now for part 3, a point is moving along the curve in such a way that the x value is increasing at the rate of this. So it means that dx by dt, because when you have a rate, it is with respect to time, it is equal to 0.012. Now we have to find the rate of change of y. So we have to find the rate. Again, rate is time, so we have to find dy by dt. So we have to form an equation. So here we have dy on top, we write dy. And we have dt at the bottom, we have to write dt. Now what connects these two? Obviously we have only one thing that connects these two is dx. So dx and dx. Of course this is here multiply. But here we know this value already, given to you by dx by dt 0.012, as you can see over here, right? Now what else do we need to know? We need to find this one, dy by dx at the value at P. Now we have to look at point P, it is 1, 3. We have to find dy by dx. So dy by dx, again, it is given to you right here at the value of P where x is equal to 1. It was found to be minus 1.5. So we just replace back in the main equation. That will be minus 1.5 times 0.012. Let's see what happened. That will be minus 0.018 units per second. That will be the rate of change of, again, as you can see here, this was done here already. dy by dx when x equal to 1 equal to minus 1.5. So we know this value, we just put this back in the equation and then multiply to find this answer right here for part 3 of your question.